In our next video, we're going to look at the definition of a horsepower. Where did it actually come from? What is a horsepower? Could we figure out how much a horse can lift or pull or push in a certain amount of time, and from that figure out what a horsepower is? And the answer is yes, that's what somebody did. Don't remember the name of the person. I guess I should have looked it up. But this is kind of what the experiment looked like. They took a horse. Of course, it looked a little better than this, but my drawing skills aren't so good, so that's the best I can do. But we had like a contraption like this with a pulley. We had a big weight sitting there. They had it attached to the horse, and then they made the horse walk forward, lifting, of course, the object up. And so what they did was they varied the weights of this object in such a way, and of course, knowing that because of gravity, we have mg, the weight of the object coming down, and of course, that's being pulled up by the tension in the string, which of course is equal to the force that the horse pulls on that string with. And so what they did was they varied the weight of that object until a horse could lift it 1 foot off the ground in 1 second. And so what they then said is they measured it afterwards, and they said, well, for that to be able to be done by horse in 1 second, and of course they picked a particular horse. I don't know if they used a whole bunch of horses and averaged it out, but if they took this one horse and said, this horse can lift 550 pounds 1 foot off the ground in 1 second, and we'll call that therefore a horsepower. So again, power can be defined as work over time, and so that is equal to the change in the energy of that object over time, or you can also define it as work over time, which is equal to force times distance over time. Either way, we're going to end up with the same equation, of course. The force is going to have to be equal to the weight of the object, which is mg, and of course the distance traveled would be the height that the object obtained divided by the time in which it was done. And so in this case, we could say, well, the change in the energy, it went from being on the ground to 1 foot above the ground. That would be an increase in energy of potential energy in this case, mga, h over time. So either way you look at it, you get the exact same equation. And so when we plug in the numbers, this was 550 pounds times 1 foot in 1 second. And that was then determined or defined to be 1 horsepower. So they call this 1 foot-pound or 550 foot-pounds per second. Another way of looking at it is, what if you put 1 pound there and have the horse run this way? Can the horse lift it up 550 feet in 1 second? Of course, that would be a little bit more difficult to do. I don't think the horse can quite run that fast, 550 feet in 1 second, so that would be the better way to do it. It turns out that 1 horsepower then in standard units is equal to 746 joules per second, which is equal to 746 watts. So that's the power that a horse can put out. Now, I'm sure there's some horses that can do better than that, and maybe some weak horses that can't. It turns out there's actually people that are, by this definition, strong, if not stronger than a horse, because some of the biggest, strongest people in the world that lift weights in the Olympics, they can lift a barbell set that's as much as 600 pounds from the ground to their shoulder. So eventually they'll be in this position right here. Right, and so here they'll be bending over, grabbing the barbell. That's quite a weightlifter. They're bigger than that, of course. But from this position up to the shoulder position in a very short period of time. Of course, this distance up to the shoulder is, probably about 4 or 5 feet, and they can do that probably within 1 or 2 seconds. So you can see that some of the strongest people in the world are actually stronger than a horse by this definition. So hopefully now you have a better understanding of what a horsepower is.